product rule and quotient rule. So to begin with, let's take a look at this derivative, which you already know how to do. There's two ways you can do this derivative, okay? One way to do this derivative would just be to do the derivative of each part, okay? We learned that we can do, when you have a sums, you can just do each part. So the derivative of 3x is 3, the derivative of 4x is 4, and the derivative of 5x is 5, and then if you added those numbers together, you would get 12. Okay, that's one way, and I'm just trying to illustrate something on this problem. The other way you could do this, which would be the smart way to do it, I think, would just be, those are all like terms. That would be 12x. So the derivative of 12x is 12. So the idea is, you learned basically that a derivative of a sum is the sum of the derivatives. So the question now becomes, does the derivative of a product equal the product of the derivatives? So let's take a look at two ways to look at this particular problem, okay? First of all, let's just write this as f of x. If you put that together, you'd have x to the 6th. When you multiply, you add exponents, okay? Now, tell me what the derivative of x to the 6th is. Okay, so we know that, okay? That's how you would do that problem, okay? So the question is, would it work if we did the derivative of x squared and then the derivative of x to the 4th and then multiply them together? It seems like it might work. Let's find out. Okay, what's the derivative of x squared? 2x. How about the derivative of x to the 4th? 4x to the 3rd. Now, if you multiply those two things, you're going to get 2 times 4 is 8. X to the 1st times x to the 3rd is x to the 4th. So it doesn't work. Okay, so that's what I'm trying to show you is you can't just do the derivative of each part like you can on sums and differences. So there's a little bit different rule that you have to apply. Does that make sense? Okay. So what we're going to learn is what we call the product rule, and any time that you're doing a problem where you have a product of two functions, you have to apply what's called the product rule. And the best way to learn the product rule is just in words. So it goes like this. If you're doing a derivative of two functions, f of x times g of x, you do the first times the derivative of the second. So I'm going to write that as second prime. Then you say plus. Then you do it backwards. You do the second. And then you multiply by the derivative of the first. So the way to learn this is probably just in words. So you do the first. You don't do a derivative of the first. Multiply by derivative of second. Then you do it backwards. Plus second times derivative of first. So that's called the product rule. So we're going to work a lot with that in this section. Okay. So let me show you how this problem would be done with the product rule. Now this one, the best way to do this problem is like this. Just go ahead and put that together to get x to the 6th. Then the derivative, you know, would be 6x to the 5th. If you were asked to do the derivative, that's the way I would expect you to do it. That's the easy way. So I'm going to show you how you could do this with the product rule. Okay, so if we're doing the product rule on this, the first is x squared. The second function is x to the 4th. So according to the product rule, you would just write down the first. Don't touch it, just write it down. Then you would multiply by the derivative of the second. It's a good idea to learn to write that as d dx of that. That means take the derivative of. Then it would be plus the second. And then times the derivative of the first, which is x squared. Now this is, I'm going to prove to you that you would get the right answer, 6x to the 5th, like that. So again, it's first times derivative of second plus second times derivative of first, okay? So let's finish it up. Okay, what's the derivative of x to the 4th? 4x to the 3rd, okay. Bring the x to the 4th down. What's the derivative of x squared? 2x, okay. Now let's simplify this and see what you get. So if you put this together, what is that? Multiply it out, what do you get? 4x to the 5th, right? Because you're adding exponents. Okay, how about the next thing? What's it? 2x to the 5th also. Well, those are like terms, so what do you get? Okay, so see, I told you so. Okay, that's how it works. Well, that's not a proof. That doesn't prove anything. But at least it proves that it works on that case. But it does work. We know that the product rule always works when you have a product of two differentiable functions. Okay, that's how that works. So does that make sense what I did? Okay, and again, you got this is a rule you're going to use so much that you need to get memorized. It's pretty easy if you learn it in words. First times derivative of second plus second times derivative of first. Okay. So this is Leibniz. Leibniz is one of the co-inventors of calculus, along with Isaac Newton. Back in the late 1600s is when this was going on. This is how it's proved. I'm not going to go over that. If you're inclined to look at that, you may. If I teach a calc class for science majors, I spend a little bit more time on proofs. So we're going to just basically learn the product rule and how to use it in this section. We're not going to really do much applications. We just kind of need to learn how to do the derivative. So let's look at this one in two different ways. So to start with, and we'll kind of talk about which way you might think's easier. Let's just multiply this out. You need to know the algebra of how you multiply this out. So let's go ahead and just start distributing. So first term, 3x times x squared is 3x to the third. Okay, then you're going to multiply these two. 3x times 3x is plus 9x to the second. Okay, then this term is 3x times 1, so that's 3x. Okay, like that. Okay, and we've done this before. Okay, now distribute the negative 4. So now you'll have minus 4x to the second. Then negative 4 times 3 is negative 12x. And then negative 4 times 1 is negative 4. Okay, so that's your multiplication. Okay, are there like terms that can be put together? Yeah, so put your like terms together. Okay, so 3x to the third will come down. 9x squared minus 4x squared is plus 5x to the second. So those go together. Also, 3x minus 4x is minus 9x. And then we have a minus 4. Okay? So you want to make sure that you're comfortable with multiplying that out. Everybody okay there? Okay. Now let's do the derivative. So we usually, when we say derivative, we usually say dy dx equals. If I say d dx, that's just saying take the derivative up. Now you guys should be able to do this with ease in your head by now. So what's the derivative here? 9x to the second plus 10x minus 9, right? And then the 4, of course, that derivative is 0. To me, that's the simplest way to do that problem. Multiply it out and do the derivative like you're used to doing. So since we're learning the product rule, there's going to be times when you have no choice but to do the product rule. So now let's do the product rule. So I'm going to write dy over dx. That's the result of the derivative. And we go like this. I'm just going to write this down. You don't have to write this down, but it's first, you can even learn it this way, f times s prime plus s times f prime. Okay, like that. So what we do is we write the first down. We don't do anything, so the first function is 3x minus 4. Then we're going to multiply by the derivative of the second. I like you to always kind of set this up in your formula like that. So that's the first times derivative of second. Now do it backwards. Now say the second. Don't do the derivative of the second, just write it down, and then multiply by the derivative of the first like that. Okay? So I like you to, when you're doing the product rule, I like you to set it up in the formula before you do the derivative. Okay? Everybody good with what I'm doing? Okay? Now what we do is we're going to do this derivative, which you should be able to do pretty easily, and you're going to do that derivative. Okay, then we're going to multiply it out. We should get the same answer. So the 3x minus 4 comes down. What's the derivative of x squared plus 3x? 2x plus 3. Okay, that comes down. Then bring down the x squared plus 3x plus 1. What's the derivative of 3x minus 4? 3. Okay, those are your basic derivative rules. Okay, now you need to multiply it out. And let's multiply it out, combine like terms, and see if we get the right answer. Okay, so we're going to FOIL this. So if we do this, I have 3x times 2x is 6x to the second. 3x times 3 is plus 9x. Inside term, negative 4 times 2 is negative 8x. And then last term, negative 4 times 3 is minus 12. So that's FOIL. Now distribute the 3, so you're going to have 3x squared plus 9x, and then plus 3 like that. So that's algebra, okay? The derivative was, the calculus is just the derivative rule. Okay, let's see if we get the same answer. So like terms, 6x squared plus 3x squared is 9x squared, okay? The x's go together. So that would be 1x plus 9x is 10x, and then negative 12 plus 3, minus 9. Which way is easier? First way. That's usually the way it is, okay? But the thing is, there are times when you have to use the product rule. So really, as a student, you see some problem like that, you probably want to just do it that way. Okay, it's less work, but that way works beautifully. Okay, so you'll see that you have to use the product rule in certain cases. Okay? Okay, same thing. We'll do one like this also. Now, do this both ways. Okay, so the way that you've already learned how to do this problem, and then I'm going to teach you in tomorrow's class what's called the chain rule, which is even easier than doing a product rule on this one, or even multiplying out. So first thing we're going to go ahead and do is let's just multiply this out. Now I want to go through it, just kind of remind you of the shortcut, because I think it's very beneficial to know the shortcut of squaring stuff. So if you square the first term, 4x times 4x is 16x squared. If you square the last term, negative 5 times negative 5 is plus 25. Then if you multiply them together, that gives negative 20x, but then you double it. So you can use this shortcut if you want to. I don't care. If you feel more comfortable foiling, then just foil. Okay, your call. But it's really beneficial to know how to square a binomial in your head. Okay, so if you multiply that out, you would have 16x squared minus 40x plus 25. Okay? Now, tell me what the derivative is.
32x minus 40.
32x minus 40. Good, that's it. Problem done. So we're going to do this one with the product rule just to kind of get you comfortable with how to do that. So I'm going to write this down as y equals, it's just 4x minus 5 times 4x minus 5. Okay, now the way I just did the problems is easier than the product rule, but we want to go ahead and do it this way. Okay, so the first and the second are going to be the same thing. So in the product rule, it would go like this. Okay, you would write the first, don't touch it, just write it, multiply by the derivative of the second. So I think it's a good idea to set it up in the product rule before you actually do the details. Then do the second, and then multiply by the derivative of the first. Okay, like that. Okay, so again, it's f times s prime plus s times f prime. Okay, like that. Okay? All right, so let's do this. What's the derivative of 4x minus 5?
4.
Just 4. Okay, right. Okay. So that means you're going to have 4x minus 5 times 4. Same thing over here. 4x minus 5 times 4. Okay? All right. Now you could do a distributive property and put this together. I'm just trying to show you get the same answer. So you would have 16x minus 20 there. And then over here, same thing, 16x minus 20. Do you get the same answer? Okay, are you convinced that you always will by now? Okay, all I can do is convince you. I can't really prove it too well in this class. So I've got 32x minus 40, you get the same answer. Okay, so really the examples that I just showed you, you're probably best off to just do it the way that you learned before the product rule. But that at least gives you an idea of how it works. Okay, so like this next problem I'm going to do, you have to use the product rule. You don't have any choice, okay, because it's already multiplied out. Okay, so this one we're just going to do the product rule on only. Okay, so let's go ahead and let's work with this just a little bit here. Okay, so I'm going to write down the product rule just for reference. And let's go ahead and put this together then. Okay, so if we do f prime of x, just get it in the formula. So you write down the first, x to the third, times the derivative of e to the x, plus the second, e to the x, times the derivative of the first, like that. Now you can do that step in your head. You can do the derivative of e to the x and x to the third. I like to, when I'm teaching it, just kind of get it set up, then move on from there. Okay? Okay, so let's see what we got. What's the derivative of e to the x? E to the x. Okay, so that comes down. Okay, and what's the derivative of x to the third? 3x squared. So those are derivative rules you know. Okay, now if you write this out, now we're going to work with this a little bit. Now you could write the answer as x to the third e to the x. And it doesn't matter what order you put it in. That's really up to you. I'm going to just kind of write it like that. So you could write the answer. That's one way to write the answer is like that. The order you put stuff in doesn't really matter on multiplication. So I'm just choosing to do it like that. Okay? I think it's a good idea to always have a constant in front of stuff and like powers of x before e and stuff like that. Now let's do one more thing with this. Let's think about factoring. Is there anything that's in common that could come out as a factor? You have x squared, right? You take the lowest exponent out. What else? So it's probably important for stuff we're going to do in the future to learn how to factor. Because really that's an okay answer. But let's go ahead and take x squared e to the x out as a common factor. Okay? So it's going to go like this. This thing right here has to be multiplied by x to get that first term, because x squared times x is x to the third, right? Okay. This thing right here has to be multiplied by a 3 to get this. So you want to know how to take common factors out. That's going to be real important when we start learning applications on problems like this. You got to factor because you're going to end up finding minimums and maximums and stuff like that. So you got to know how to do that. Okay, so do you guys see the factoring okay? Okay, now that's background stuff that you're going to encounter. Okay, I'm going to go ahead and let you guys do one problem, just one problem on this. And I want you to do this both ways. This one just multiply out first, then do the derivative, do it that way, and then redo it with the product rule. And I'll write the product rule up here. Okay, see if you get it. So again, I think the way I do this, just multiply it out. Okay, so if you multiply it out, you want to make sure you did that okay. You would have x to the fourth plus 5x squared minus 4x squared minus 20. Okay, if you did that. Now, if you do the derivative, okay, what did you get for your derivative? Actually, I guess you got like terms you can put together on this too, can't you? I didn't see that. So that's y to the fourth plus x squared minus 20. Okay? So what's the derivative? Do I have a y? No, that's x. Sorry. Okay. What'd you get? 4x to the third plus 2x. Is that good? Okay. All right. Okay. Now, just wanted to see if you got the product rule. So you want to set this up like this. Okay. You would just go the first times the derivative of the second, and then backwards, plus, and then the second times the derivative of the first, like that. Okay, I do recommend when you're learning this that you write that out like that. But you can actually do that derivative in your head, those parts of that if you want to. So this would be x squared minus 4. This derivative here is just 2x, is what you should have got there. Then you have plus x to the second plus 5. And then this derivative right here should be 2x. So that's how it's set up. Right, everybody okay? Okay, do a distributive property. So you're going to have 2x to the third minus 8x to the first. Same thing here. Plus 2x to the third plus 10x. If you combine your like terms, it should have given the same answer, right? So you got 2 and 2 is 4. X to the third. And then plus 2x. Okay, is that working okay for everybody? Okay. All right, so that's kind of what you're going to be looking at for the product rule to start with. Anytime that it's easier to multiply first, just do it that way. But like this example 3 I did here, you have to use the product rule on. Okay, so that's kind of an important thing to catch on to. Okay, next thing we're going to look at is a quotient rule. There's the other rule we learned in this section. So I want to just show you, if you were doing a quotient of two functions, like you have a x to the fifth is the numerator and x to the third is a function in the denominator, the way that you would want to do this problem is, well, you could subtract those exponents, and if you simplify x to the fifth over x to the third, it's really x to the second, right? So what's the derivative of x to the second? 2x. Okay, that's the correct derivative of that. Now you can simplify, then do a derivative. So the question becomes, would it work if we did this? If we did the derivative of the numerator and we did the derivative of the denominator. If it works, then that's great. Let's find out. Okay, what's the derivative of x to the fifth? 5x to the fourth. Derivative of x to the third? 3x squared. Okay, what is x to the fourth over x to the second? X to the second. You subtract exponents, right? That's the algebraic property. So do you get the same answer? And you do not, so it doesn't work. So just like the product, you can't just do a derivative of each part. You can't do that on a quotient either. So you have a quotient rule, okay? So this is the next rule that you got to learn, okay? This is a big deal in calculus. So this one goes like this. If you're doing a derivative of a quotient, f of x being the top and g of x being the bottom, then it goes like this. You do the bottom times derivative of top minus top times derivative of bottom over bottom squared. So I recommend that you just learn this in words, and when you start crunching these things out, you will get these rules down because you're going to use them all the time, okay? So just think of it as bottom times derivative of top minus top times derivative of bottom all over whatever the bottom is squared, okay, like that. That's the product, that's the quotient rule. Now this is the proof. I'm not going to go over the details of the proof. You should probably look at that and see if that makes sense. The point that I try to make in this class on the proofs is that notice it all comes from difference quotients when you're dealing with derivatives. So this is why the quotient rule works, okay? Okay, so let's do this one, this example with the quotient rule, even though we already know the answer, then we'll start kind of practicing the quotient rule. So if you were doing this problem the easy way, you would simplify that to x to the second, and then if you do the derivative, you would get 2x. So without a doubt, that's the derivative of that function, okay? Now let me write this down for reference, okay? The derivative of the quotient rule is bottom times derivative of top minus top times derivative of bottom over bottom squared. You don't have to write that down. I want to write that down so you can kind of refer to this as we put this together. Okay, so let's do it this way and see if we don't get the same answer. Okay, so you would take the bottom, which is x to the third. You would multiply by the derivative of the top. Let's just write it down as you're doing the derivative of the top. Okay, that's that part of it. And then it's minus, then it's the top, times derivative of bottom. Okay, then all over the bottom squared. So the bottom is x to the third, and then you're going to square that whole thing like that. Okay, and there's algebra issues that are going to pop up in this. Okay, so that's how that goes. Bottom, derivative of top, minus top times derivative of bottom over bottom squared. Does everybody see how it's set up? Okay, now what we have to do is got to do this derivative and that derivative, which are easy. You should know how to do that by now in your head. So this is x to the third. This derivative I got highlighted in yellow is 5x to the fourth. Then you bring down the x to the fifth. Derivative of x to the third is 3x to the second. What is the bottom? Is it x to the fifth or x to the sixth? Okay, that's a background thing again. Okay, the thing is that you got to know is the rules for exponents go like this. If you're multiplying, That's when you add the exponents. If you have something like this, that's when you multiply your exponents. Okay, that's the algebra that's going to show up here. Okay, well, let's finish it up and see what we get. So if I put this together and this together, what I would have is this is 5x to the 7th. This is minus 3x to the 7th over x to the 6th. Okay, the numerator has like terms, so 5 minus 3 is 2x to the 7th over x to the 6th. So what's x to the 7th over x to the 6th?
2x.
X to the 1st, right. Okay, you subtract exponents. See, the other rule, and these rules of exponents are incredibly important to know because they're going to show up constantly. That's kind of shows you when you subtract, when you add, and when you multiply your exponents. So yeah, that's going to be just 2x. So obviously this problem's a heck of a lot easier to do the first way, but the quotient rule would work like that, okay? And then the rest of these examples, you're going to have to use the quotient rule on. Okay, tell me if you follow what I'm doing with the quotient rule and all the algebra, okay? All right, let's work out some quotient rule and see if we can do this okay. I'll do a couple of them and then let you try to do one. Okay, so this one, you have no way to simplify this. Nothing factors, and whenever you have a rational expression, the only way to simplify is factoring, and there's no factoring. So we have to immediately just go to the quotient rule. Okay, so we're going to go ahead and put this in the quotient rule. So we'll have the bottom, like that, multiplied by the derivative of the top. And you want to go ahead and kind of get it set up. And then you do it backwards. Now this time it's minus, then it's the top. And then you're going to multiply by the derivative of the bottom. And that will be all over the bottom squared like this. The quotient rule, you can get into some messy algebra sometimes, depending on the situation. So these we're going to start kind of pretty straightforward. Okay, bottom derivative top, top derivative bottom over bottom squared. Okay, so next thing to do is go ahead and do these two derivatives that I've got highlighted and just kind of bring stuff down. So the x squared minus 3, leave it alone. Derivative of 3x plus 5 is what? 3. What's the derivative of x squared minus 3? 2x. So we're going to have a 3 there, and then minus 3x plus 5, and then times 2x. Now the bottom, you want to leave that squared, and this is pretty important. You do not need to take the time to multiply out the bottom. You never do, because your goal sometimes, that's already factored, so it's sometimes you'll have a little cancellation come out. So you don't want to ever multiply that out. Now we're going to do this distributive property here. So we're going to do multiply the 3. So that's 3x squared minus 9, like this. Now be real careful with this minus. Watch this carefully. You don't want to slip up here. That's going to be minus 6x squared. Okay, because so you really have a minus there. And then same thing here. 2 times 5 is 10, but you have that minus. This piece of the problem right here, when you have minus 3x plus 5 times 2x, really what's happening is this is distributing through that, leaving you that. Okay, so that's a place where a lot of times students slip up, is on the minuses right there. So watch that real carefully when you're doing the quotient rule. Okay, then what I'm going to do is just bring the bottom down, like that, and then you'll have some like terms, so put your like terms together. So if I do that, I've got negative 3x to the second. Doesn't really matter what order you put stuff in. Then I'm going to put the minus 10x. I kind of like to put the x's in a certain order, what we call a descending order, so it goes like that. And then that should be it. The only other thing that you attempt to do on these problems is see if you can factor the numerator. And that I don't think that factors. You could play with it, and I don't think you're going to get anywhere with that factoring. But it's a good idea to try. So that's it. Leave the bottom squared. That would be your derivative like that. Don't do anything with that. There's hardly ever any time you're going to do anything with that. Because every now and then, like about one time out of maybe 50 times, that numerator will factor and then it'll cancel with whatever's in the bottom. That's why you leave that left. Okay? All right, any questions? Okay. All right, let me do a couple more, then I'll let you work with that a little bit in class and see how we do. So let's do this one. This one, what you have to do is you have to use the quotient rule on this one. You can't simplify, you can't factor, so you're just going to have to go directly to the quotient rule. Okay, so let's go ahead and get that together. What you're going to do is you say the bottom, 1 plus e to the t, and then you say the derivative of the top, and then minus, and then do it backwards, then do the top, and then do the derivative of the bottom. And then when you do, it's one big fraction, so you got a big fraction bar, and it's the bottom squared. Okay, so that's the setup. Again, bottom times derivative of top minus top times derivative of bottom over bottom squared. Okay, so what you have to do is the calculus comes from setting up and then doing these two derivatives. Okay, all right, tell me what the derivative of 1 minus e to the t is.
Minus e to the t.
Minus e to the t, because the derivative of 1 is 0, right? That minus is a constant, so it's there. That's really like a minus 1, if that helps you. That's like that. What's the derivative of 1 plus e to the t? E to the t. Okay, so you're going to have those kind of things showing up in the problem. Okay, so let's write down what we have. We still have the 1 plus e to the t. Then this is going to be times negative e to the t. And then minus 1 minus e to the t. And then times e to the t. All over 1 plus et to the e to the t to the second power. Now that is an unsimplified derivative right there. Now watch what I do carefully here, because what you get into a lot here is algebra. You have two choices here. It doesn't matter which way you do, but one way is easier than the other. You could distribute. You could do that if you want to. But one of the things that you always try to do on these problems is factor. Okay? And sometimes the factoring to a calculus student's a little more complicated than what they've seen before. Those are the two terms right there. You got this thing as a term, because that's a product of two things. What do you see that's in common in those two things? E to the t, right? These are not the same. 1 minus e to the t and 1 plus e to the t is not. So you can take that e to the t out. And this is the way you want to learn to do this. When you're doing a quotient rule, you want to look for factors. That's real important. So watch carefully. I'm going to take e to the t out. Okay, and then I'm going to draw like a big bracket there. Now, one thing I'm going to do to kind of help you process this, I'm just going to kind of mark that out in my mind. Okay, so what would be left is, you still have that negative there, and then you have 1 plus e to the t like that. You still have this minus here. And then if you take e to the t out, you have parentheses 1 minus e to the t. All right, so a lot of times in this class,
where did that first negative come from?
it was already there from that derivative. Okay, so we did that. So what I've done is I've taken the e to the t out. This thing comes down. I just put the negative in front. And then that thing comes down there. Does that make any sense? Look for that. When you're doing quotient rule, look for common factors instead of multiplying out. It's easier. Okay. Now, we're still going to have the bottom squared like this, so that's going to come down. Okay. Now, we are going to multiply this thing out right there. We're going to see if we can put that together then. Okay. So you're going to have some things you can do inside there. So I'm going to still have that e to the t. Now, let's distribute the negatives through. So you're going to have minus 1 minus e to the t. And then this second one, you're going to have minus 1 plus e to the t like that. Okay, again, all I'm doing is just distributing. Minus 1 minus e. Minus 1 plus e. Okay, these are the kind of things that students slip up on in calculus more than the calculus is the algebra. So we got that. Now, inside, what happens inside the parentheses? What do you see?
1.
Right, okay, these cancel out, okay. And then you have negative 1 minus 1 is negative 2. So what you would have is you would end up having negative 2 e to the t all over 1 plus e to the t squared. Okay, the hardest part of that problem for most students is algebra, not calculus. And that's what you're going to get into in the quotient rule. We're kind of at the point in the semester when we work with these derivative rules. This is when you're going to challenge your algebra background, big time. Because you're going to get, and if you simplify those to the end the way I want you to, you'll get stronger with your algebra. So learn to look for common factors. You guys understand the algebra? Tell me. This is what I encounter. It doesn't matter if I'm teaching business calc or calc for science majors. The algebra is the big part for students in this part. Okay, I'm going to do one more, and then I'll give you a little time to try one. Okay, this one you're going to have to use the quotient rule on. Okay, so just start up by setting it up. Okay, so I do the bottom. Okay, then times the derivative of the top. Okay, then it's always a subtraction sign, then backwards. You do the top times the derivative of the bottom. Now we have an ln this time, which we learned what that rule was today. So we have that. Then it's going to be all over big fraction bar 2 plus ln x to the second. So that's the setup like that, and then you need to do the derivatives. There's going to be times on these problems where the simplification's a little more complicated, like the last problem. Sometimes pretty easy. Okay, what's the derivative of 4x?
4.
What's the derivative of 2 plus ln x?
2 over x.
No,
Half x.
careful, 1 over x. Because if you're doing that, the derivative of 2 is 0. The derivative of ln x we learned today is 1 over x. You're thinking 2 times ln x, okay? So we have that. Okay, so let's put it together and see what kind of simplification we have. So we have 2 plus ln x here times 4 minus 4x times 1 over x, and then all over the bottom square. Okay, now that's not simplified. So what do you notice happening here? What happens? X's cancel out, because see, that's 4x over 1, and then here you could just do a distributive property. Okay, so what you're going to look at, see this piece of the problem right here, what you really have is 4x over 1 times 1 over x. X is crossed out, so that's going to leave you a 4. Okay, and then here you can just distribute. So you got 4 times 2 is 8, and then you have 4 ln x, and then that right there, the x's cross out, leaving you 4, all over 2 plus ln x to the second like that. Okay, so let's see, we have like terms. 8 minus 4 is 4 plus 4 ln x over 2 plus ln x squared like that. Okay, now there's one other thing you could do with this problem. That right there is an acceptable answer, but you do want to get in the habit of factoring. So can you factor that numerator in any way? There's 2 terms. Is there anything in common? 4. You can pull a 4 out. I'm going to go ahead and do that because I want to get you in the habit of always looking for factoring. So if you pull a 4 out, you would have 1 plus ln x all over 2 plus ln x squared. Now what will happen is, I want to just mention something to you. If this had turned out, if it turned out to be 2 plus ln x, then that would cancel with one of those, right? So those are the kind of things you want to look for. Every now and then that will happen. That's the reason you want to develop that habit. Actually, either of these answers is okay. But it's good to try to take it all the way to the factoring to the end. Okay? Okay, your turn. I'll let you guys try this one. I'll give you a little time to see if you can do that. Okay, I'll write the quotient rule up here too. So it's bottom times derivative of top, top times derivative of bottom over bottom squared. So go ahead and take a little time, see if you can get that one put together. the setup here. Okay, so the setup, just get it set up in your quotient rule formula. Now let's see where the algebra takes us on this. So what's the derivative of this first part?
3x to the second plus 1.
Okay, and then this part. So that's kind of nice. That's just 1. Okay, all right. So what we'll have here is this will come down. You'll have x minus 4, and then you'll have 3x squared plus 1 minus x to the third plus x times 1, and then all over the bottom squared like that. Okay, now one thing that you usually kind of look at is see if you do have any common factors. There really isn't anything in common. So you just need to FOIL this out, multiply that out, and collect like terms. And that's what you needed to do on that problem. There really isn't anything else you're going to be able to do. So let's go ahead and let's FOIL this and then distribute this and then see where that takes us. So if you FOIL this, you're going to have 3x to the third and then plus x minus 12x to the second minus 4. Now what is this minus going to do to these parentheses? I'll change the sign, so be careful. That's minus x to the third minus x. And of course you're multiplying it by 1. And then you would have all over the bottom squared. Okay, and I'll just see if you got your like terms together, and let's see if they'll take us anywhere. So 3 minus 1, that would be 2x to the third. And then the x's cross out. Okay, and then you have a minus 12x to the second minus 4 all over x minus 4 squared. If you got to that point, you're doing fine with your calculus and your algebra. Is there anything else you could do to the numerator? You can take a 2 out. Now that's the only thing that you can take out, so I would be okay, like if you left it there, you're okay, but I do want you to go ahead. Anytime you can factor, start getting in the habit of doing that. Whoops, so that would be, did that wrong. That would be x to the third minus 6, x to the second minus 2, all over x minus 4 to the second. So the algebra on that one was not too bad. Okay, how's that look to everybody? Okay, that's your quotient rule. Now I'm going to do this next example, just one more tangent line, because you're going to keep revisiting this. And then I think we can probably, the last couple of problems we should be able to finish up with. So what we're going to do on a tangent line is, again, you're going to work with this formula. Okay. And then this time I gave you a point. So this time you're going to have, that's going to be x1. And negative 2 is going to be the y1. So what do you need to do to find n? You need to do a derivative using the quotient rule and then evaluate that at negative 1. Okay? All right, so we need to go ahead. The big work on this problem is going to be doing the quotient rule. Okay, so let's go ahead and get that put in. Okay? All right, now this time I'm going to kind of go like this. I'm going to do a step in my head, which you can do. You do the bottom. Now, what is the derivative of the top in your head?
2x.
2x. So see, you can do that if you want to. I'm okay if you do that. Okay, once you start practicing, that's what you'll start doing. Then minus the top. Okay, and what's the derivative of the bottom? 1. That's kind of cool. Okay, so we have that. And then we have the bottom squared. Okay, so you can do it like that. Okay, then this one, just multiply it out. Multiply the numerator out, so that's going to be 2x to the second minus 2x. What's this minus going to do? I keep asking because that's where students mess up all the time.
Minus x squared minus 3.
Very good. Okay, be careful with that. Okay, all right. Okay, now let's see if we got like terms. Okay, so it looks like 2x squared minus 1x squared is x squared minus 2x minus 3 all over x minus 1 to the second. Okay. There's a chance that that factors. The numerator looks like it might. I'm going to go ahead and try. Okay, let's see if that factors. Okay, so if we just look at the numerator, you're going to have x and x to get x squared. You're going to have 3 and 1 to get that. And you would actually have a minus and a plus, so that does factor. Now, it doesn't end up canceling anything out. But if it did cancel out the x minus 1 on the bottom, then you'd want to go ahead and do that. So that's the reason you don't want to overlook that. So that would be your quotient rule derivative. Now what you need to do is you need to plug in the -1, because you're finding the slope of the tangent line at that x value. So what you need to do now is you're really doing f prime of -1. So you can plug it in either place. You can plug it into the factored form or either here or there. Let's just plug it into the second way. So that's -1 minus 3 times -1. Oh, I love that. Okay, do you guys know what the answer to this is? It's 0, okay? Yeah, okay, because see, this thing right here is really -4 times 0 over -2 squared. Well, that's 0 over 4, so it's 0. So that means m is equal to 0, okay? And there's a lot of, just a little algebra on that one, so you're going to end up having 0 like that, okay? All right, now let's go ahead and let's work it out and see what we get then. So you're going to have y minus -2 equals 0 times x minus -1, like that. Okay, so that's the setup. Let's go ahead and do this then. It's nice when this is 0. That's y plus 2. What's the right side going to be?
0.
Okay, all right. So if you solve for y, you would just get y equals -2, which is a horizontal line. Okay, so we're going to just finish up class. We'll go ahead and do a little graph on our calculator. So the only thing different about the problem is you had a quotient rule. So the derivatives are getting a little more complicated now. So let's put this in the calculator and kind of see if this looks visually correct to us here. So the way you'd want to do this is like this. You'd want to put the function in. Now when you put this function in, you got to have parentheses around the whole numerator. So you'd have x squared plus 3. And then divide by, that would be x minus 1, so it has to go like that. Okay, and then the second equation is y equals -2, which should just be a horizontal line. So you're going to have a rational function. Does this rational function have an asymptote anywhere? Vertical asymptote? Where's this thing undefined? At 1. So yeah, you're going to see a vertical asymptote coming out at 1 on this. So I'm going to go ahead and just put kind of a little dashed line on there. Okay, let's graph it and let's just kind of draw a little sketch and see if it looks right to us. Okay, it does not have a horizontal asymptote. It has a slant asymptote to it. So what you're going to find on this is, yeah, you've got, this is your tangent line right here. Okay, you got this point. So you have the point -1, -2. So I'm going to go to put that point right there. Then all I'm going to do is just make a rough sketch. This doesn't have to be perfect, but you are going to kind of approach that asymptote like that, kind of approach kind of down like this, and then you have some shape up kind of like that. Does that look right? Does it look like that's a good tangent line? Okay, yep, okay. So visually, a lot of times you can tell that you're right. That looks like a good tangent line on it, okay? Okay, so see, now we're starting to get